Today I want to show you how to solve equations when there are variables on both sides. So what I mean is you've got variables on the left side of the equal sign and you've got variables on the right side of the equal sign. So when you solve, you've got one goal. And your goal is to get the variable on one side of the equation and the numeric terms on the other side of the equation. So what I mean is you've got to pick the variables need to go either on the left or the right side of the equal sign, and then your numbers, just the constant term, needs to go on the other side. You may need to simplify by using combining like terms or distributive property. So now let me show you an example of the biggest mistake that might be made. Students look at this first example and say, okay, 5x and 2x is 7x, and they rewrite it. This is absolutely not okay. All right? The reason this is not okay is because you can't jump over that equal sign. All right? You cannot cross that barrier. Right? You need to get rid of the 5x or get rid of the 2x, but you cannot cross that equal sign and combine like terms. That is an illegal move in math. So let me show you how you really do it. So now the trick I want to show you is look at the variables and see which one is smaller. You've got 5x and you've got 2x. 2x is smaller, so my suggestion is to get rid of the smaller variable. The reason why is because you avoid negatives. All right, there's no big thing about it, but I know you don't like working with negatives. So if you want to try to avoid them, get rid of the smallest number. So that's a positive 2x, so you need to subtract 2x from both sides. It might be best if you draw that division line, and that's just there to remind you not to cross that barrier. So 5x minus 2x is going to give you 3x. 2x minus 2x leaves you nothing but your positive 14, and then you've got a regular two-step equation. All right, so get your numeric terms, get the constant on the other side, get rid of that positive 2 by subtracting 2 on both sides, and that gives you 12. I know it's one step now and you can solve that. I'm not worried about that right now. We'll be doing this tomorrow. I just want you to see how you need to get the variables on one side and the numeric terms on the other side. One thing I want to show you is what would happen if you didn't get rid of the 2x. What would happen if you got rid of the 5x? It's not a big deal at all. But like I said, it would leave you with the negative. Okay? If you want to avoid the negatives, then go with the trick of getting rid of the smallest variable, and you'll avoid the negatives. You will, however, come up with the same answer. Okay? Just because it's a negative, it's not going to change the answer at all. And we'll go over those tomorrow in class. So if you look at the second example, which one is smaller, your 4W or your 7W? Your 4W, that is the second time I've done that. Hang on, please. Okay, your 4W is smaller, so get rid of your 4W first. These are going to cancel out and leave you with, careful, a negative 10 is equal to 3W. And then you can get rid of your numeric terms, get rid of that positive 2 by subtracting 2 on both sides, which would give you negative 12 is equal to 3W. Again, I'm not going to solve all the way. I just want to show you how you get your variables on one side and you get your numeric terms on the other side. Okay? Doesn't matter if your variables are on the right side or the left side, you just need to get them on one side. Okay? Finally, I want to talk to you about identities and no solution. If the two sides of the equation are equal, there are infinitely many solutions. 1 would work, 2 would work, 3 would work, 7.3 would work, all right? And it's an identity. If the two sides are not equal, there's no solution. No number will ever make it equal. All right? So what I mean by this are these examples. If you look at the first one, 2x minus 4 is equal to 2x minus 4. Well, if you look at that, they're exactly the same. All right? They're equal. This is an identity. If some people can't see that, they might say, okay, get the variables on one side. So I'm going to subtract 2x, whatever I do to one side, do to the other, subtract 2x. That gives me negative 4 is equal to negative 4. They might say, well, that's equal. I'm not solving for anything that's equal. Exactly. That's an identity. All right? The left side is equal to the right side. It's an identity. Every single number that you could possibly think of will make that equation true. Now, if you look at the other side, 3x plus 7 equals 3x plus 2. Right? They're not the same, so solve. So get rid of 3x. Whatever you do to one side, do to the other. You're going to get 7 is equal to 2. Is that a true statement? No, that's not equal. Nothing that we could ever do will make it equal, so that one has no solution. Right? We are going to talk about these more tomorrow. I will see you then.